Hello learners, I hope all of you are doing good. I welcome you all to the third lecture on high voltage testing and measurements of Module 5 on electrical measurement instrument of the online course on electricity and electrical wiring. I am Dr. Shankar Moni Bora from the Department of Applied Sciences, Guwahati University, Guwahati, Assam. So learners, in this session, we are going to discuss about the various methods of high voltage testing, its measurement types and purpose. This lecture will also help you in understanding about calibration, maintenance, and the use of different high voltage measuring instruments. In today's lecture, we will focus on the following topics. Number 1, methods of high voltage testing, then methods of high voltage measurements, followed by calibration of various measuring instruments, and finally, maintenance of various measuring instruments. The learning objectives are to explain the concept of high voltage, to discuss about different high voltage testing methods, to study about the various methods of high voltage measurements, to get an idea about calibration of different measuring instruments, and finally, to explain about the maintenance of such measuring instruments. Now let us begin with the question, what is high voltage testing? In electrical engineering, high voltage testing is defined as the process which is used to ensure safety, efficiency, and reliability of various electrical components, equipment, and systems like electrical machines, circuit breakers, insulators, etc. under high voltage condition. High voltage testing is usually performed on such electrical devices and equipment that are considered to be in high voltage systems like generating stations, transmission and distribution stations, etc. Such type of testing is an essential testing method to determine the reliability, performance, and safety of high voltage devices and equipment such as power transformers, high voltage switchgear, high voltage line insulators, transmission line conductors and cables, and many other high voltage electrical components. So now, let us understand about some of the important factors related to the purpose and importance of high voltage testing in the field of electrical engineering, which are as follows. First, to determine the insulation performance of the equipment. The high voltage testing helps in determining the strength and quality of electrical insulation used in the equipment. It can provide information on the amount of electrical stress the insulation can handle without breaking down. Second, to determine risk and ensure safety. Here, the high voltage testing is an important method to evaluate how safer the equipment is. It is an important factor to understand for equipment mainly used in public places. Third is to determine safety standards. It is also important to ensure that the equipment in use meets the prescribed norms of national and international electrical standards such as IEEE standards, IEC standards, etc. Fourth, to detect manufacturing defects and to ensure equipment quality. It is performed on very high electric voltage. If there is any manufacturing defect or low quality material is used, it will be revealed during the testing process, which might not be visible under normal operation. And lastly, to determine the lifespan of equipment. The excess amount of electrical stress that is applied on the equipment during the high voltage testing helps in predicting the lifespan of the machine or the component. So now, we will discuss about the various methods of high voltage testing. There are several types of high voltage testing which are as follows. One of the method is known as the dielectric breakdown test. The dielectric test of electrical equipment is an important testing method to determine the electrical insulation property of the insulating material that is used in the equipment. This test determines the highest value of the voltage that the insulation material used in the equipment can handle without breaking down, which is important to ensure the safety and reliability of the equipment. The dielectric breakdown test ensures the quality of the insulating material and the operational safety of the equipment. Next, let us discuss about the flashover test. The flashover test is an electrical test performed to determine the voltage value at which a flashover occurs over the surface of insulators. A flashover is an electrical discharge which occurs between conductive parts due to high electric voltage. This high voltage test is important to determine the following parameters: the strength and quality of the insulating material, and to ensure safety. Again, it ensures that the equipment comply with the industry standard. It also ensures a safe operational and overvoltage limit that the equipment can withstand without breaking down. Next, the high potential test. The high potential test, also called high pot test or dielectric withstand test. The main purpose of this test is to determine the quality of material used in insulation and components so that the equipment can withstand the suitable high voltage without any failure. This test ensures the following: quality and effectiveness of the electrical material, detect manufacturing defects and contaminations in the material, comply with the prescribed industry standards, etc. Now, let us discuss about the high voltage DC test. This test is performed on electrical equipment which are used in high voltage direct current systems. The primary purpose of this test is to determine the insulation strength and performance of electrical equipment and components when they are operated on high voltage DC supply. In practice, this test is commonly used in testing of equipment used in high voltage direct current transmission systems. This test is used for the following purposes: to avoid failure of equipment due to low insulation strength under normal operating conditions, determine the insulation strength under high voltage DC stress, and to ensure proper operation of high voltage direct current equipment. Now, let us study the high voltage frequency test. In high voltage electrical systems, insulation failure of equipment mostly occurs due to high frequencies in power supply. These high frequencies are basically the results of switching and other transient phenomena. As such, some tests are carried out to ensure that the insulation material used in the equipment can withstand the high frequency conditions. So, in high voltage testing, a high voltage frequency test is performed by which it can be determined as to how the insulation material and other components respond when they are subjected to a high frequency voltage. The high frequency voltage test is mainly used to test the performance of electronic components used in radio frequency circuits and high frequency power transformers. The purpose of the high voltage frequency test are as follows: to determine the response of insulation material and other components under high frequency electrical voltage, to estimate the performance of electrical insulation under high frequency operating conditions. Another important test is the insulation resistance test. This test is an important test performed under the high voltage testing procedure. The purpose of this test is to determine the electrical resistance of the insulation material used between the conducting components and the earth or ground. This test used to assess the following conditions: quality of the electrical insulation between conducting components, identify the major insulation problems, ensure electrical safety and prevent accidents, ensure that the equipment comply with industry standards. Next, let us discuss about the partial discharge test. The partial discharge test, also known as PD test, is an important test which is used to determine the insulation health of material used in electrical equipment. The PD test is a localized electrical breakdown that occurs within the insulation material used in the equipment. This test is used to detect and monitor the partial discharge, which helps in ensuring the safety, reliability, and providing longer life to the equipment. Therefore, the main objectives of the partial discharge test are: determine insulation health of the electrical material used in equipment, prevent insulation failure and maintenance, ensure the quality of the insulation material, longer equipment life, and safety. Now, we will discuss about the sustained low frequency test. The sustained low frequency test is another high voltage test which is performed on high power electrical equipment like power transformers, transmission lines, cables, circuit breakers, etc. This test is used to determine the dielectric strength of insulating material when they are operated under low frequency voltages for a long period of time and at power frequencies of 50 or 60 Hz. The following are the main objectives of the sustained low frequency test: to determine the insulation capability of materials under prolonged application of low frequency voltages, to evaluate the reliability of the material under normal operating frequencies, to determine the strength and the probability of failure of insulation that may cause electrical hazards, and to ensure that the insulating material complies with the requirements of industry standards. Now, finally, let us study about the surge or impulse test. There is an electrical test in high voltage testing of electrical equipment which is called the surge test or the impulse test, and it is used to determine the insulation strength and capability to handle transient voltage, also called surges. This test is generally performed on electrical equipment which are subjected to switching or lighting surges, and it provides a measure of reliability of electrical equipment under transient or unstable operating condition. The purposes of the surge test or impulse test are: to determine the capability of electrical equipment under transient conditions, to determine the probability of insulation failure due to transients, to evaluate the performance and reliability of insulation under short duration high voltage spikes. Dear learners, let us do a self-check of our learning so far by attempting the following questions. After attempting the quiz questions, we will now go ahead to learn about the different methods of high voltage measurements. There are again a number of methods of high voltage measurements. Some of the common methods are briefly discussed in this section. One of the direct methods of measuring high voltages is by electrostatic voltmeters. Direct measurement of high voltages is possible up to nearly 200 kilovolt, and various types of voltmeters have been designed which can be connected directly across the test circuit. For voltages above 10 kilovolt, usually the attracted disk type of electrostatic voltmeter is used. Electrostatic voltmeters of the attracted disk type may be connected across the high voltage circuit directly to measure up to 200 kilovolt without the use of any potential divider or other reduction method. The force in these electrostatic instruments can be used to measure both AC and DC voltages. The Abraham voltmeter is the most commonly used electrostatic meter in high voltage testing equipment. High voltages are also measured by stepping down the voltage by using transformers and potential dividers. The use of the primary voltage to estimate the secondary voltage is a fairly rough method of measurement but is applied for most AC tests. In the transformer ratio method, the voltage on the low voltage side of the high tension transformer is measured. The actual voltage across the load is not measured. In the series resistance method, a high series resistance specially designed to withstand high voltage and resistance of 20 kilo ohm per volt is used with a microammeter having a 50 microampere movement. This method is applicable for both AC and DC. A number of resistances are used in series, and to prevent leakage current, the whole system is enclosed inside an insulated container which is arted for shielding purposes. As a safety measure, a safety gap or neon lamp is connected across the microammeter. By using a stable supply of accuracy 0.10% and accuracy of 1% is possible by this method. When this method is used for alternating voltages, there occurs the effect of distributed capacitance too, which can be reduced by providing a suitable screen or by balancing the capacitance. In the resistive potential divider method, a high resistance potential divider is connected across the high voltage winding, and a definite fraction of the total voltage is measured by using a low voltage voltmeter. But for alternating conditions, there will be capacitance disturbance. One method of eliminating this is by having a distributed screen of many sections and by using an auxiliary potential divider to provide fixed potential to the screens. The capacitive potential divider method is used for alternating work where a capacitive potential divider is used in place of the resistive potential divider. Here, two capacitances are used in series and the electrostatic voltmeter is connected across the lower capacitor. The sparkover of sphere gaps and other gaps are also used, especially in the calibration of meters in high voltage measurements. The sphere gap method of measuring high voltage is the most reliable and is used as the standard for calibration purposes. The breakdown strength of a gas depends on the ionization of the gas molecules and on the density of the gas. Therefore, the breakdown voltage varies with the gap spacing, and for a uniform fill gap, there is high consistency. So the sphere gap is very useful as a measuring device. In the measuring device, two metal spheres are used, separated by a gas gap. The potential difference between the spheres is raised until a spark passes between them. The breakdown strength of a gas depends on the size of the spheres, their distance apart, and a number of other factors. A spark gap may be used for the determination of the peak value of a voltage wave and for the checking and calibrating of voltmeters and other voltage measuring devices. The density of the gas, normally air, affects the spark over voltage for a given gap setting. So the correction for any air density change must be made. The spark over voltage for a given gap setting under the standard conditions, that is 760 torr pressure and 20 degrees centigrade, must be multiplied by the correction factor to obtain the actual spark over voltage. In the case of asymmetrical gap, there are two breakdown characteristics, one for the positive high voltage and the other for the negative high voltage. Since the breakdown is caused by the flow of electrons, when the high voltage electrode is positive, a higher voltage is generally necessary for breakdown than when the high voltage electrode is negative. However, when the gaps are very far apart, then the positive and the negative characteristics cross over due to various space charge effects. Because this occurs well beyond the meaningful operating region, under alternating voltage conditions, breakdown will occur corresponding to the lower curve, which is in the negative half cycle under normal gap spacing. So, under normal conditions, the AC characteristic is the same as the negative characteristic. When the spark gaps are to be calibrated using a standard sphere gap, the two gaps should not be connected in parallel. Transient voltages are recorded using oscilloscopes. High voltage oscilloscopes are used for the study of fast transient phenomena, particularly on high voltage and on spark breakdown in small gaps, which have a high sweep speed. Since the speed is high, the intensity is lowered, and so a higher intensity is required. Here, the beam should not come on till the transient comes in, because if it is stationary, the spot of high intensity will fog the photograph before the transient comes on, and if it is moving, the beam may have swept before the transient comes. Therefore, the beam should be brought on just before the transient comes on by being triggered by the transient. The transient should come on the Y plate only shortly after the beam, so that the whole transient is clearly seen. For this, a delay cable is used. The delay cable ensures that the transient appears slightly after the beam comes on. The oscilloscope can display a maximum of about 50 volt to 100 volt, and thus the impulse voltage must be reduced by a suitable potential divider, which reduces the applied voltage without producing any distortion, meaning that the ratio of the potential divider does not vary with time or frequency. The potential divider can be of two types, namely resistive and capacitive. Lightning surges, the most spectacular of the high voltage phenomena, can be recorded using the cleidonograph by the surges it produces on the transmission lines. But still, there is very little information about its effects and the voltages of the surges that appear in the transmission lines due to it. The frequency of occurrence of surge voltages and the magnitude of the surge it produces on the transmission lines is studied using Lichtenberg patterns obtained by using this device. Cleidonograph has a dielectric sheet with photographic film which is used in this device. A plain electrode is on one side and a pointed electrode contacts the film. High voltage is applied to the pointed electrode and the plain electrode is grounded. The photographic film rotates continuously inside a black box to prevent light exposure. Now let us discuss the operation of the cleidonograph. When impulse voltage is applied on the high voltage electrode, it creates filamentary streamers on the photographic film. Patterns known as Lichtenberg patterns form on the film without visible discharge between electrodes. Flashover or visible discharge exposes the film and prevents patterns. Both positive and negative voltage surge types show increasing pattern radius with increasing voltage. The next topic which we will now study is about the calibration of various measuring instruments. Calibration is a method by which a comparison between a known measurement, known as the standard, and the measurement using the instrument in use is done. Generally, the accuracy of the standard must be 10 times the accuracy of the measuring device being tested. However, an accuracy ratio of 3:1 is acceptable by most standards organizations. By understanding the fundamentals and applying good practice, it is possible to ensure the quality of results in a wide range of industrial and scientific applications. Calibration of various measuring instruments has two important objectives, which are as follows. Number one, it checks the accuracy of the instrument in use as well as it determines the traceability of the measurement. Number two, Practically, calibration also includes repair of the device if it is out of calibration. In order to explain how calibration is performed, an external micrometer can be used as an example. Here, the accuracy of the scale is the main parameter for calibration. Further, these instruments are also calibrated for zero error in the fully closed position and flatness and parallelism of the measuring surfaces. A calibrated optical flat is used for this purpose. For the calibration of the scale, a calibrated slip gauge is used. Calibration is important to maintain the accuracy of measurement of instruments. The accuracy of all measuring instruments degrades over time. This is usually caused by normal wear and tear. Further, changes in accuracy can also be caused by electric shock, mechanical shock, or a hazardous manufacturing environment like oils, metal chips, etc. It is essential to calibrate the measuring instruments according to the recommendation of the manufacturer after any mechanical or electrical shock, and also periodically, which can be either monthly, quarterly, or annually. Further, the hidden cost and risk associated with uncalibrated measuring device could be much higher than the cost of calibration. Therefore, it is recommended that the measuring instruments are calibrated regularly by a reputable organization to ensure that errors associated with measurements are in the acceptable range. Finally, let us discuss about the importance of maintenance of various measuring instruments. Proper maintenance of various measuring instruments is essential to ensure accurate and reliable measurements, compliance with industry standards, and optimal performance in various industrial applications. Neglecting regular maintenance can lead to measurement errors, equipment failures, and also compromise in the product quality. Some of the important measures which helps in maximizing accuracy and longevity of measuring instruments are: number 1, record a maintenance schedule. A hands-on maintenance schedule for the measurement instruments to ensure regular upkeep and monitoring of their condition should be maintained, including a maintenance plan which includes periodic inspections, cleaning, lubrication, and calibration checks based on the manufacturer's recommendations, uses frequency, and environmental factors. Also, there should be a maintenance log to track maintenance activities, document instrument performance, and schedule upcoming calibration tasks to prevent equipment downtime and ensure consistent measurement accuracy. Number 2, clean and protect the instruments. A clean and dust-free environment for the measurement instruments should be ensured to prevent contamination, damage, and interference during their operation. The instrument surfaces, displays, lenses, and sensors should be regularly cleaned using appropriate cleaning solutions, soft brushes, and lint-free cloths. Also, the instruments have to be kept in protective cases, cabinets, and designated areas to shield them from exposure to harsh chemicals, moistures, heat, and physical impacts. Sensitive components like probes, sensors, and connectors needs to be protected from debris, corrosion, and wear to extend the lifespan and reliability of the instruments. Number 3, perform regular calibration. Calibration of the measurement instruments at regular intervals to verify their accuracy, repeatability, and consistency over time should be ensured by following the manufacturer's calibration procedures, guidelines and recommended calibration frequencies to maintain measurement traceability and compliance with quality standards. Calibration checks before critical measurements, after significant events, or when there are signs of measurement deviations must be done by using certified calibration standards, reference materials, and calibration laboratories to ensure the accuracy and reliability of the calibration process. Number 4. Train personnel on proper handling and maintenance. Steps should be taken to impart comprehensive training to operators, technicians, and maintenance personnel on the proper handling, operation, and maintenance of measurement instruments from time to time. Further, the users should be made aware of the instrument's functionalities, limitations, safety precautions, and best practices for handling, storing, and transporting the instruments. They must also be trained on correct measurement techniques, calibration procedures, and troubleshooting methods to minimize errors, prevent damage, and optimize instrument performance. Number 5. Monitor instrument performance. There should be a method to regularly monitor the performance, trends, and historical data of the measuring instruments to identify potential issues, deviations, or abnormalities in measurements by using software tools, data logging systems, and statistical analysis techniques to track measurement data, trends, and variability over time. Also, one should monitor instrument drift, stability, and repeatability to assess the requirement for recalibration, adjustments, or maintenance interventions. This can be done by alarm systems, alerts, or notifications to signal when instruments are approaching calibration limits or exhibiting unacceptable measurement errors. And lastly, number 6, document maintenance and calibration records. There should be a detailed record keeping of all maintenance activities, calibration results, and instrument performance data to track the history, traceability, and compliance of the measuring instruments. This can be done by recording a comprehensive log of maintenance schedules, calibration dates, calibration certificates, etc. Also, there should be proper documentation of any repairs, replacements, upgrades, or modifications made to the instruments to ensure transparency, accountability, and auditability of the maintenance and calibration processes. All documentation should be kept in a secure and organized system for easy access, retrieval, and reference during audits or quality inspections. Dear learners, as we have come to the end of the discussion of this section, let us test our learning by attempting these questions. So learners, in today's session we have discussed about the importance of high voltage testing in measuring instruments. We have also learned about several types of high voltage testing methods like dielectric breakdown test, flashover test, high potential test, high voltage DC test, high voltage frequency test, insulation resistance test, partial discharge test, sustained low frequency test, and surge or impulse test. We have also learned about various high voltage measurements. Finally, we have understood about the importance of calibration as well as proper maintenance of various measuring instruments. I hope the information given in this video will help you to enhance your knowledge about high voltage testing and measurements. Thank you for watching this presentation.